Hello everyone, a very good evening to all. Myself Vivekananda Naik, I am a PhD research scholar in the Department of Energy Science and Engineering, IIT Delhi. So today I welcome you all once again for this 8th interaction session on NPTEL Course Experimental Physics 1, which is being flowed this July 2025 session with course code NOC 25 PH 51. So today we will be solving a few sample problems that will be based on the week 8 course content or lectures of the course in experimental physics 1. So the content of week 8, if we discuss, then it contains demonstration of the experiment of compound pendulum. So the theory regarding compound pendulum, then experimental demonstration of the standing waves on a string, and then determination of linear mass density of the string uh, where the experiment was performed. And these two are correlated. Then theory regarding linear expansion of metal, that was also discussed in this week's content. So we will be solving a problems. We will solving a few problems. So as we start solving problems, then depending upon the type of problem, then we will discuss about the concept a few briefly about the concepts of the underlying problem. So let's start the first problem of the day. The question says the time period of a compound pendulum is T. Now, if the mass of the compound pendulum is made 4 times, length of point of suspension from center of gravity 2 times, and the moment of inertia about the point of suspension is doubled, then what will be the new time period of the compound pendulum? The options are option A T by 2, option B T, option C 2T, and option D T by root 2. So question says the time period of compound pendulum is T. So old time period was T. Now if the mass of the pendulum is made 4 times, so m prime become 4m, length of the point of suspension from the center of gravity. So suppose this is d prime, this is now 2d, and the moment of inertia about the point of suspension is doubled. So moment of inertia, suppose it is doubled. Then what will be the new time period? Then what will be the new time period that we need to find? So I'll give you a few minutes to try to solve this question. Then we will discuss briefly how it will be solved and what will be the correct option. So if we discuss about compound pendulum, unlike simple pendulum, it has some center of gravity due to its mass distribution. So the information we need is the mass, moment of inertia about the axis that pass to the point of suspension, and the length of point from the suspension center to the center of gravity. So how we in general, if you talk about the theory regarding compound pendulum, then the uh, when it is suspended, then the weight of the particle at the center of mass that produces a restoring torque about the suspension axis, and that torque is given by minus mg d sine theta. Then if you use the concept of small oscillation, and then if you solve, what you will find, the simple harmonic motion equation can become double derivative of theta plus mg d divided by I into theta equals to 0. So this is a equation of simple harmonic motion, equation of simple harmonic motion. So if you compare this with the normal equation, which is y double prime plus omega square y equals to 0, then it becomes omega square is mg d by I root over. Then the time period of oscillation, it is given by t equals to, t is 2 pi by omega, so it becomes 2 pi root over of I divided by mgd. So we will use this formula. So we have t is equals to 2 pi I divided by mgd. So now, according to the question, m becomes 4 times, distance is doubled, and the moment of inertia is also twice. So new time period of oscillation will be t prime equals to 2 pi square root over I prime divided by m prime. G fixed, it is acceleration due to gravity, which is a universal constant, so g can be changed, and d prime, so it will be 2 pi I prime is 2I divided by m prime is 4m into g into d prime is 2d. So I prime is 2I, d prime is 2d, and m prime is 4m. So this is the condition given in the question. So if you solve it, then we found 2 pi. So these two gets cancelled out. I divided by mgd root over into 1 by 2, square root of 4 is 1 by 2, so which will be in the denominator. So this 2 pi I by mgd is t, so t by 2. So the new time period will be half of the earlier old time period. So the correct option will be option A. I hope this was clear to everyone. So in the question it was mentioned that the time period of a compound pendulum was t. Now the mass was increased to 4 times. The moment of inertia about the point of suspension, that about the axis that is passing through the point of suspension, that became 2 times, and then the point, the distance of the point from the center of gravity, that was doubled. So what will be the new time period? So we know the equation of, for the relation for time period of oscillation given by I divided by mgd square root into 2 pi. So if we put the new values of I, d and m, then we will get the new time period as T by 2. So I hope this is clear to everyone. Now we will move to question number 2. So question number 2 says, calculate the approximate value of the time period of a compound pendulum having moment of inertia about the point of suspension equals to 20 kg per meter square, 20 kg into meter square, mass 4 kg, and center of gravity lies at a point 20 centimeter below the point of suspension. So suppose so you need to find out the, so let's discover the options. Options are option A 2 second, option B 5 second, option C 10 second, and option D 12 second. So the approximate value of the time period of compound pendulum. So the moment of inertia about the point of suspension, it is given as 20 kg into meter square, mass is 4 kg, and the distance from the center of gravity is 20 centimeters. So these are the information that we have been given in this question, and we need to find out the time period of compound pendulum. So what will be the time period? So I'll give you a few minutes to try this question and solve it, and then we will discuss what will be the correct option. So if we solve it, it is really a straightforward one. So we know the time period of oscillation for a compound pendulum is given by 2 pi I divided by mg d, where I is the moment of inertia, m is mass, g is acceleration due to gravity, and d is distance of point of suspension from center of gravity. So we know I is 20 kg into, so I is 20 kg into meter square. M is given as 4 kg, and the distance between center of gravity and the suspension point D is given 20 centimeters. So in order to convert into meter units, it is 0.2 meter. So if we put all the values, then T will be 2 pi square root 20 divided by 4 into 9.8 into 0.2. So if we solve it, T will come out to be 10.035, so which is nearly equal to 10 seconds. So the time period of oscillation for a compound pendulum with the information given in the question is 10 seconds, and the correct option is option C. I hope this is clear to everyone. Now we will move to question number 3. Question number 3 says, calculate the moment of inertia of a compound pendulum about the point of suspension having the time period of 4 seconds, mass 4 kg, and center of gravity lies 40 centimeter below the point of suspension. Options are option A 6.36 kg into meter square, option B 2.89 kg into meter square, option C 4.22 kg into meter square, and option D 1.05 kg into meter square. So this question is pretty much similar to the previous question. However, the unknown quantity that we need to determine in this question is different. So in the question, the moment of inertia and all the other informations were given to us, and we needed to calculate the time period of oscillation. But here it is reverse case. We need to find out the moment of inertia of a compound pendulum and the time period, mass, and center of gravity distance from point of suspension is given. So we will again use the same formula. T is equals to 2 pi I divided by m g d square root. So using this formula, we will calculate the value of I. So I'll give you a few minutes. So let's try this question and solve it, and then we will discuss. So if we solve it, so T is 2 pi I divided by m g d square root. That implies t square is 4 pi square I divided by m g d. That implies I equals to t square into m g d divided by 4 pi square. We have t equals to 4 second, mass is 4 kg, and d is 40 centimeter. So in terms of SI unit, 0.4 meter. That implies 4 square into 4 into 9.8 into 0.4 divided by 4 pi square. So 4 gets cancelled out. 16 into 9.8 into 0.4 divided by 3.142 square. So if you solve it, it will give you 6.36, and the unit is kg into meter square. So the correct option will be option A, 6.36 kg into meter square. So now, uh, before solving problems related to the coefficient of thermal expansion, so let's discuss a few things about thermal expansion. So what is thermal expansion? So thermal expansion is the tendency of a matter to change its shape, area and volume in response to a change in temperature. So because we have thermal conductivity, so due to that thermal conductivity, the as a part of that effect, when the temperature is changed, there is a tendency of the matter to change its shape, area and volume. So the relative expansion, that is the strain, that we had already discussed about different types of when we are discussing at the initial weeks of our discussion, we are discussing about coefficient of elasticity. So there we discussed about stress, strain, and how the coefficient of elasticities are defined. So the relative expansion, that is actual expansion in comparison to the original length, which is called as strain. It is divided by the change in temperature, is called as material's coefficient of thermal expansion, and it varies generally with temperature. So there are three types of thermal expansion corresponding to the dimension expansion involved. So the linear thermal expansion, is calculated for the objects for which the change is predominant along a single direction. Similarly, for aerial thermal expansion, the change is noticeable or dominant along the two dimensions, and the third dimension is not that measurable or um, much effective. Then third one is volumetric thermal expansion, so which is a three-dimensional expansion. So what is linear thermal expansion? So when a heat is applied on a body, its length expands proportional to the original length, then or changing the temperature. What is aerial thermal expansion? Its area expands proportional to the original area, and volume, its volume expands proportional to the original volume. So corresponding to these three types of expansion, we have three different type of coefficient of thermal expansion. So if you discuss about more details, so let me add a new slide. So if we talk about thermal expansion, so suppose delta L is the thermal expansion. Suppose thermal expansion. So let's talk about linear thermal expansion. Linear thermal expansion. So suppose delta L is the change in length, then delta L will be directly proportional to the original length, that is L0, and the change in temperature. It is obvious because if the change in temperature is more, then there will be mm, more change in the original length. So there is a proportionality constant which is written as delta L equals to alpha L0 delta T. So this alpha is known as coefficient of thermal expansion. So now let's solve a few problems based on those concepts. Now the question says a steel rod has a length of 100 centimeter at 30 degrees Celsius. Now, so if you see here, uh, what is the unit of thermal expansion? It is Kelvin inverse. So we'll discuss about it more in the this problem that we'll be discussing now. So a steel rod has length of 100 centimeter at 30 degrees Celsius. So at 30 degrees Celsius, the length is 100 centimeter. What will its length at 250 degrees Celsius? So we need to find out the length at 250 degrees Celsius, and given the coefficient of the linear expansion of steel is 12 into 10 to the power minus 6 per degree centigrade. So here you, if you see also it can be represented as degree centigrade. So what is the coefficient of linear expansion? It is given as 12 into 10 to the power minus 6 degree Celsius inverse. So options are option A 100 into 2 100.264 centimeter, option B 100.3 centimeter, option C 100.087 centimeter, and option D 100.14 centimeter. So these are the four options. So based on the concept that we discussed now, we need to solve this question. So I'll give you a few minutes to try this question and try to solve it, and then we will discuss what will be the correct answer. So if we solve it, we know delta L is equals to alpha L0 delta T, that implies alpha is equals to delta L divided by L0 into delta T. So here you see delta L and L0 both have same unit, so the unit of alpha is equals to the inverse of delta T, that is inverse of temperature. So if we are talking about temperature in degree centigrade, then it will be degree centigrade inverse. If we are talking about in Kelvin, so it will be Kelvin inverse. So that's why in the question it is given as 250 degrees Celsius, and the coefficient is also given in per centigrade. So we don't need to convert into Kelvin or any other units of temperature. So we need to find out the coefficient of sorry we need to find out the length at 250 degrees centigrade. So uh, so L0 is 100 centimeter, which is at 30 degrees Celsius, and L1 we need to find, which is at 250 degree centigrade. So what is delta T? Delta T is 250 minus 30 equal to 220 degree centigrade. So we know alpha is sorry delta L is alpha L0 and delta T. So and alpha is given, alpha is 12 into 10 to the power minus 6, delta T we got 220 degree centigrade, and L0 is 100 centimeter. So what is L? So so first we need to find delta L. Delta L is alpha L0 into delta T. Then L1 will be L0 plus delta L. So what is delta L? Delta L is equal to alpha L0 into delta T. So alpha is 12 into 10 to the power minus 6 into L0 is 100 plus sorry into delta T is 220. So we can get the value of delta T, but directly we can found the value of L. So L1 will be L0 1 plus alpha T. So how this formula came? So like here you see L1 is equal to L0 plus delta L. So L0 plus alpha L0 delta T. So if you take delta L, if you take L0 common, then it will be 1 plus alpha delta T. So 1 plus alpha delta T. So L0 is 100 into 1 plus alpha is 12 into 10 to the power minus 6 into 220. So if you calculate, it will be 100.264 centimeters. So this is the correct answer. And if you see the options, 100.264 centimeter, that is option A is the correct option. So with increasing temperature, the length also increases. So and the increase in length will again depend upon the original length and the coefficient of linear expansion and the temperature difference. So with the information given in the question, we calculated and we obtained that the new length at 250 degrees Celsius will be 100.264 centimeter. I hope this is clear to everyone. Now we'll move to question number 5. Question number 5 says a brass rod is heated through 250 degrees centigrade and its length becomes 80 centimeter. What was its length before heating given the coefficient of linear expansion of brass is 20 into 10 to the power minus 6 per centigrade. So it is a bit different from the previous question. So the options are option A 79.05 centimeter, option B 79.45 centimeter, option C 79.6 centimeter, and option D 79.85 centimeter. So in the previous question, the original length was given, and with increasing temperature, the change in length or the new length was asked in the answer. But here it is given that when we heat the rod or brass rod to over a temperature difference of 250 degrees centigrade, then its length becomes 8 centimeters. So we need to find out its original length, that is we need to find out L0, and the value of L is given to us, and the coefficient of linear expansion is also given to us. So alpha is given to us 20 into 10 to the power minus 6 per degree centigrade. L1 is given to us, which is 80 centimeter, and delta T is given to us, which is 250 degree centigrade. So we need to find out the value of L0. So I'll give you a few minutes and then we will discuss. So if we solve it, so we know delta L is alpha L0 delta T. So L1 will be L0 1 plus alpha delta T. That implies L0 will be L1 divided by 1 plus alpha delta T. So L1 is given to us 80 centimeter, alpha is 20 into 10 to the power minus 6 per degree centigrade, delta T is 250 degrees Celsius. So L0 will be 80 divided by 1 plus 250 into 20 into 10 to the power minus 6, should be 80 divided by 1 plus 250 into 250, so 5 into 10 to the power minus 3, it is 80 divided by 1 plus 0.005. So L0 is 80 divided by 1 plus 0.005, 80 divided by 1.005. If we solve it, it will be 79.6. So the correct answer is option C, 79.6. So since we need to find the original length always will be smaller than the length at higher temperature. So here it is less than 80, which is 79.6. And how much it will be lesser, it depends upon the coefficient of expansion. If the coefficient is more, then there will be more expansion, because it is a direct, so it is direct proportional to the coefficient of expansion also. Since, but coefficient of expansion is not a variable, it is constant for a particular material, and it varies when the material changes. Now let's move to question number 6. Question number 6 says a rod of initial length 120 centimeter is heated through 80 degrees Celsius and its length increased to 120.12 centimeter. Find coefficient of linear expansion of the rod. Options are option A 12.5 into 10 to the power minus 6, option B 14.5 into 10 to the power minus 6, option C 15 into 10 to the power minus 6, option D 18 into 10 to the power minus 6. So these are the four options. And what the question says, so initial length, that is L0, is 120 centimeter and it was heated through 80 degrees centigrade and its length increased to 120.12 centimeter. So again we will use the same formula and we only need to find out the value of coefficient of thermal expansion. All the other unknown quantities are given to us in the question. So I will give you a few minutes to solve this question and then we will discuss. So we know delta L is alpha L0 delta T. So now what is delta L? Delta L is equal to L minus L0. So 120.12 minus 120. So 0.12 centimeter. So 0.12 centimeter is equals to alpha L0 delta T. L0 is 120 centimeter, delta T is 80 centimeters. So what is alpha? Alpha is delta L divided by delta T into L0. So alpha L is equal to delta L divided by delta T into L0. So delta L is 0.12 divided by delta T is 80 into the L0 is 120. So if you calculate, so 120, 0.12 by 120, it will be 1000. So 1 by 8 into 10 to the power 4. Sorry, 1 minute. So 1 by 8 into 10 to the power 4. So what it will become? It will be 12.5 into 10 to the power minus 6 per degree centigrade. So the answer is 12.5 into 10 to the power minus 6 per degree centigrade. So the correct option is option A, 12.5 into 10 to the power minus 6 degree centigrade. Now we move to question number 7. Question number 7 says, if change in length is plotted along y-axis and change in temperature is plotted along x-axis, then the slope of the curve will give option A, coefficient of linear expansion, option B, coefficient of linear expansion into initial length, option C, coefficient of linear expansion divided by final length, option D, coefficient of linear expansion divided by change in length. So let me write the symbol. So coefficient of linear expansion is alpha. Coefficient of linear expansion into initial length, so alpha into L0. Coefficient of linear expansion divided final length, so alpha divided by L, or alpha divided by delta L. So these are the four options. Now what is given in the question? Change in length is plotted along y-axis. So this is x, this is y. So change in length, that is delta L, is plotted along y-axis. This is the origin, and change in temperature is plotted along x-axis. So delta T is plotted along x-axis. So it is change in T. This is change in L. So if we suppose this is a line we draw, then what will be the slope of the curve? That we need to find out. So if this is the line, then what will be the slope? We will determine. So if we see the situation is given, uh, this is x-axis, this is y-axis, delta L is along y direction, delta T is along x direction. So we know about this is the line and this is theta. We know the slope is given by tan theta, which is delta y by delta x, that is delta L by delta T. So now we need to find out what this quantity implies. So we know alpha is delta L divided by L0 into delta T, that implies delta L divided by delta T, it will be alpha into L0. So that means coefficient of linear expansion into original length. So the correct answer is coefficient of linear expansion into original length, option B. So I hope this is clear to everyone. Now we'll move to the questions based on standing wave, because as a part of the week's content, an experiment was performed to determine the linear mass density by calculating the by studying the concept of a standing wave in a straight string. So I'll be back in a few minutes and then we will discuss. So let's discuss about briefly concepts of wave and standing wave. So wave is a disturbance in a medium that carries energy without a net movement of particle. So basically it carries energy but there is no movement of particle. So it may take the form of an elastic deformation or variation of pressure, electric or magnetic field intensity, electric potential or temperature. So it is basically a disturbance or variation of a quantity that carries energy but without any movement of the particle. So it can be deformation. So deformation is also a wave. Then variation of pressure. So the quantity varying quantities pressure, then electric and magnetic field, which is called as electromagnetic wave. So when an electromagnetic wave propagates in a medium, then there is variation of electric and magnetic field. Then electric potential also varies, and temperature. So if you talk about the basic physical quantities associated with the wave, so one is wavelength. So this is called as crest and this is trough. So this is crest and this is trough. So the distance between two crests or two trough, it is called as one wavelength, and the maximum distance from the zero value is called as amplitude. And if you see, the one complete oscillation is given as, this part is called as one oscillation. So the frequency is the number of oscillation per 1 second. And if you talk about different types of waves, so in mainly there are two types of waves: transverse wave and longitudinal wave. So in transverse wave, what happens when the wave that moves in a medium, waves in which the medium moves at right angles to the direction of the wave. So when a wave propagates along a direction, when the quantities varies along the perpendicular direction, that is called as transverse wave. For example, water wave, light wave, stringent instruments, or torsion wave. For example, light wave, which is called as electromagnetic wave. So that we will discuss in the next slide. Then the high point of a transverse wave is a crest. The low point is trough. So high point, this point is called as crest, and this point is trough. And if you talk about longitudinal wave, so longitudinal wave is the movement of the wave is along the same direction as the movement of the medium. For example, sound wave and compression wave. So sound wave, uh, there is a compression and rarefaction. The wave moves along the same direction as the direction of compression and rarefaction. So if you talk about the longitudinal wave, compression where the particles are close to each other, and rarefaction where the particles are spread apart. So let's take the example of a sound wave. So basically this light wave, this is a transverse wave. So because it propagates along this direction, so k vector is called as wave vector or propagation vector. It is along, suppose this is along x direction, then as you can see, this is the electric field which is varying along y direction, and this is the magnetic field which is varying along z direction. So the wave propagates along a direction which is perpendicular to both the variation of quantities direction, that is x, wave is propagating along x direction, whereas the quantities vary along y direction, z direction. So this is called as transverse wave. So how a standing wave is formed? Basically, a standing wave is formed when two waves having equal amplitude and frequency, and they move along two different direction. For example, this is the case. So suppose these are two fixed points. So one wave, suppose this wave, it is propagating along this direction, and this dotted wave, it is propagating along another direction. So here the two waves, they are propagating along opposite direction, but they have same amplitude and same frequency. That's why they form nodes and antinodes. So the point where the two waves, the minimum of the two waves matches, it is called as node, and for maximum it is called as antinode. So why it is called as standing wave? So because it looks stationary, the point that doesn't move, it is called as node, because these points, they don't move, they don't move. And antinode is the point which oscillate with maximum amplitude. So this point, they oscillate with maximum amplitude. So same frequency and same amplitude move opposite direction, they form standing wave. Then how interference is occurred? So same frequency and same frequency or same or different amplitude wave moving along same direction. So when they move along same direction, this is called as interference. This is the example of interference. So you see here two waves are given here. So this is one wave in orange, another wave in green. So if they interfere constructively, then their amplitude increases, and if they interfere destructively, their amplitude decreases. So it depends upon the initial phase difference. So when the phase difference is 180 degree, then uh, they will interfere destructively. If the phase difference is 0 degree or this basically 0 degree, then they will interfere constructively. So that lead to of amplitude, that may lead to higher amplitude in case of constructive interface, and lower amplitude in case of destructive interference. And now slightly different frequency and same amplitude moving in same or opposite direction, they form beat. If you talk about the concept of wave, so wave is represented by an equation y is equal to a sin omega t. So here you see it is minus omega t, so its movement is in minus x direction. Plus omega t, movement is in. So this symbol, this two, that represents the direction of motion and the phase. So kx minus omega t. So if you talk about the two waves, so let's add another slide. So, for example, let's discuss about superposition of the two wave. Suppose one wave, this is y1. So y1 is a sine kx minus omega t. So it is moving along plus x direction. Y2 is a sine kx plus omega t. It is moving along minus h direction. So when we superimpose it, so y will be y1 plus y2. So if you calculate, it will be 2a sin kx cos omega t. So the sin kx is special factor and cos omega t is temporal factor. So a few things, if you so in general, kn is given by n pi by l. Suppose l is the total length, then k is the number of modes, and omega n, it is again given by vkn, which is n pi v by l. And in general, for nth mode, we can represent y n xt, which is equal to an sine n pi x by l. So this sine kx is n pi x by l, and cos omega t cos omega n t. So these are a few things. Now let's solve a few problems. So question 8 says standing waves are produced in 4-meter long stretched string. If the string vibrates in 5 segments and the wave velocity is 200 meter per second, then what is the frequency? Options are option A 125 Hz, option B 200 Hz, option C 250 Hz, and option D 150 Hz. So these are the four options. So what it says, standing waves are produced in a 4-meter long straight string if the string vibrates in 5 segments. So suppose this is the string, the length of the string is 4 meter. This is point A and this is point B, and the standing waves are produced. The vibrates in 5 segments. So there are 5 segments in 4 meter. The wave velocity is 200 meter per second and the length is 4 meter. Then what will be the frequency? So I'll give you a few minutes to solve this question, and then we will discuss about the correct answer. So if we solve it, so it had 5 sections. So suppose 1, 2, 3, 4, 5. So it will be like so now. So this so we know this part, this is lambda. So 2 section is 1 lambda. So 5 section is 2.5 lambda. So 2.5 lambda is 4 meter. That implies lambda is 4 by 2.5, so 1.6 meter. So there is a relation between wavelength, velocity and frequency. So frequency is equals to velocity by wavelength. Velocity by wavelength. So velocity is 200 meter per second and wavelength is 1.6 meter. So if you calculate, it will come out to be 125 hertz. So hertz is basically second inverse. So the correct answer is 125 hertz and correct option is option A. I move to question number 9. So question number 9 says, for a standing wave given by y is equal to 2 cos pi x by 20 sine 200 pi t, the distance between one node and the next antinode is, where x is in centimeter. So options are option A 5 centimeter, option B 10 centimeter, option C 40 centimeter, and option D 50 centimeter. So a standing wave is given. So y is 2 cos pi x by 20 into sine 200 pi t, and we need to find the distance between one node and next antinode. So see here, so this is one node, so this is node and this is antinode. So let's draw the picture again. Suppose this is a, so this is antinode, this is node, and we need to find the distance between the two. So basically if this is lambda, then the distance between node and antinode, it will be lambda by 4 centimeter. So I'll give you a few minutes and then we will discuss what will be the correct answer. So one thing also you see, so at node, amplitude is 0, at antinode amplitude is maximum. So if we use this, then at node amplitude is 0 or minimum, at antinode amplitude is maximum. So we know node is at, so node is always at x equal to 0. So for antinode, a node will not be at x equal to 0, because here the amplitude is a equals to 2 cos pi x by 20, because if you see the, so this is the amplitude part, so 2 cos pi x by 20. So when it is maximum, so when x equal to 0, cos 0 will be uh, so at x equals to 0, a will be 2 into cos 0, cos 0 is 1, so 2 into 1 equal to 2. So since a2 is the maximum, amplitude, so x equal to 0 is a antinode. Now for node cos pi x by 20, it will be 0, which is cos pi by 2, because cos pi by 2 is 0, cos 90. So pi x by 20 is equals to pi by 2. So x is 20 by 2, that is 10 centimeter. So delta x will be 10 minus 0, that is 10 centimeter. So the distance between one node and one antinode. So x0 is antinode, x10 is node. So the distance between one node and one antinode is 10 centimeter. I hope this is clear to everyone. Now I will move to the last question, that is question number 10. So question number 10 says, if the tension of sonometers wire increases 16 times, then the fundamental frequency of the wire will increase by, options are option A 2 times, option B 16 times, option C 1 by 2 times, and option D 4 times. So uh, so what is the fundamental frequency? So the fundamental frequency is given by the formula fundamental frequency. It is given by the formula 1 by 2L T by mu, where T is the tension. So the fundamental frequency is direct proportional to root of tension. So when T becomes 16 times, F will become root over of 16 times, so 4 times. So F prime will be 4F. So fundamental frequency will be 4 times. So the correct option is the correct option is option D, 4 times. So what do you mean by fundamental frequency? It is also called as fast harmonic. So the fundamental frequency, it is the lowest frequency at which the string vibrates. So since the frequency is lowest, so its wavelength will be maximum. So suppose this is a string. So what will be the fundamental frequency wave? So this will be the fundamental frequency wave. It has only one antinode and two nodes. This is fundamental frequency. So in this case, this is lambda by 2. So lambda by 2 is L or lambda is 2L. And depending upon the, so this fundamental frequency is also called as fast harmonic, and the other harmonics is given by Fn equals to n f1, where n is 1, 2, 3 like that. So n is equal to 1 is fundamental, 2, 3 they are of higher harmonics. Second harmonic, third harmonic. So second harmonic is also called as fast overtone, like that. So with this we come to the end of today's interaction session. I hope the problems that I have solved in this interaction session will help you in solving the assignment problems that we are getting in the course and also for your exams. With this, I come to the end of today's session. That's it for my side.